hello to all of you. We're going to be moving on to a chemistry topic now. So I know this is math class, but we're going to be talking about chemistry a little. We're going to be talking about half-lives. So we have this problem. Suppose we have 100 grams of ZN78. I'm not a chemist. I don't even know what that is. I don't even know if that's a real element. I just kind of made it up. Which has a half-life of 4 days. So what half-life means is we're starting at 100, and then we're going to lose half of that 100 after 4 days. And then after another 4 days, it's going to split in half again. After another 4 days, it's going to split in half again. It's going to keep on splitting in half. So we get questions like this. How much will remain after 31 days? How many days will it take for there to be 21 grams? And before we get into thinking about those things, we want to construct the formula. So we have a couple formulas we need to remember over here. So these formulas, I'm going to write them over here, but it doesn't mean they only apply to A or they only apply to B. Let me make sure everything's in shot. Yeah, we're good. So this first one is we need to find what's called the K constant. So we denote this as K, and we say K equals ln of n, or my bad, ln of 2. Someone's having a good time out there. Over our half-life. We denote this as t to the 1/2. So ln of 2 over whatever the half-life is, which is 4 days. Let me get a calculator. I apologize if you guys can hear that. Someone's jamming out the quad, so while I'm trying to record. Yeah. So for this one, we have ln of 2 over, we said our half-life is just 4. And we get 0.17. So that's our K, that's our decay constant. So now we got to use, I'll give you guys the rest of the formula. So the final, I'm using the letters F and I again. You can use whatever letters you want. If you look it up on the internet, it's going to give you different letters. I just use F and I because it kind of reminds me of, okay, this is final, this is initial. So F equals, the final equals the initial times E. And then what makes this different from the growth kind of formulas that we saw was the amount of grams we have, the final amount of grams is going to be decreasing over time, right? Because it's just going to split in half every couple days. So we're actually going to have a negative exponent, and it's going to be negative K T. T does not, talking about the half-life by the way, it's being used for questions like this, like how many days will it take? How much will remain after 31 days? That's what T is talking about. It's not, we're not plugging in 4 for T. Okay, so let me just kind of annotate this. I said F. This is talking about final amount. I is talking about the initial. And then the negative is always there. K, this is just the K constant that we found. And then T, as always, is just time. Like I said, if you guys want to use different letters, feel free to do that. You don't need to use the same letters I use. Okay. Now, let's fill in the pieces. So F equals, I equals, K equals, T equals. And I hope you guys can kind of notice, I did all of this before I even read the problem. I think that's kind of just a practice you guys should get familiar with. Okay, before we even read what's going on here, let's kind of get things laid out so that when we do read the problem, we're kind of ready to break things down. Okay, so now this question's asking us, how much will remain after 31 days? So from here, we see that the time is going to be 31. And then we got to go back to the original problem because it says Suppose we have 100 grams, so that's what we're starting with, is 100. And then K is our decay constant, which is just 0.17. And it says how much will remain after those 3 days. So the final is what we're looking for. We're looking for how much will be left in the end. Okay, let's plug everything in. So we got F equals, I is just 100 times E to the power of negative 0.17 times T is going to be 31. If you guys just want to throw all this in your calculator right now, feel free to do that. You can do that. You can break it up into little pieces. I'm just going to throw it all in the calculator. And then, you know I don't edit my videos. If one of you guys want to edit them, feel free. Brother, does this thing not have an E? Ah, right there. E to the power negative 0.17 times 31. I'm sorry guys, you're just gonna have to hang in with me. These calculators are not great. There we go. 600 negative 0.17 times 31. Okay. And so we get F equals, I got 0.51. So he's gonna have 0.51 grams after 31 days, which should make sense because if it's splitting in half every 4 days, that means after 31 days, it's pretty much gonna be gone. But with this, you see that it's never actually all gone. It's just gonna keep on getting closer and closer and closer to 0. Since it is following an exponential curve, it's just gonna keep getting closer to 0, but it's never actually gonna hit 0. So for our final answer, just 0.51, it's that easy, you just kind of plug it in your calculator. So that's an easy problem. You guys really don't need to be taught about that. This problem is gonna make things a little bit trickier. You're gonna have to kind of use the skills you did in the last video and the couple units before this. So once again, I'm doing the same thing. I haven't even read the problem. I'm just gonna identify F equals, I equals, K equals, T equals. Okay, so now I'm gonna read the problem. How many days will it take for there to be 21 grams? So the time is what we're looking for, and then it's saying for the final, it wants 21 grams, so 21. And then now we can go back to the original problem, and we know that we're starting with 100, and then we're just going over there. The decay constant doesn't change. It's still gonna be 0.17. Okay, we're using our formula again. So we have, it's the same formula right here. It doesn't matter if the problem's changed, we're still using the half-life formula. It's just the only difference between these two problems is we're solving for F in the first one, and we're solving for T in this one. So we're still using 21. You know, I know a lot of you guys don't watch this with sound, so I'll just write the formula again. This is the formula we're using. F, I, E to the negative K, T. So if we're replacing the parts, it's 21 equals 100 E to the power of negative 0.17 T. All right, so now our first step with all these is we got to divide both sides by whatever is in front of the E. So in front of the E we have 100, we want to get rid of that. So we divide both sides by 100. These cancel out. 21 divided by 100, oh, I'm an idiot. 0.21. So we get 0.21 equals e to the power of negative 0.17 times t. Now we're gonna get to a point where we get a little stuck, hopefully. And now you need to remember, okay, we're trying to solve an exponent. We got rid of everything in front of the exponent. There's no pluses or minus after this. We just got the e to the power of something. And your mind should always shift now to, we're gonna use natural log, because that's just log base e. So we have ln of 0.21 equals ln of e to the power of negative 0.17t. I just kind of compressed that all into one just to make things a little bit easier. Okay, so now that tells us we're allowed to move this to the front of our natural log, and we're left with ln of 21 equals negative 0.17t times ln of e. And if you guys remember, this is magic right here. ln of e is magic because it just equals 1, so we can cross it out. Because we're just going to be having 1 times negative 0.17t, which is going to give us negative 0.17t. So I'm going to move everything up here. We're just left with ln of 0.21 equals negative 0.17t. We divide both sides by negative 0.17. These cancel out. We get t equals, we grab our magic calculator, 0.21. We get 9.18. So since t in this case is talking about the amount of days, that tells us that it's going to take 9.18 days for whatever this magic chemical is to get to 21 grams. And that's your little chemistry lesson in the math class. Thanks, you guys.